Okay, so since yesterday we graphed in this form, today we're going to graph in this form. So yesterday we learned that this makes it either go really, really skinny or wider. And what did C do? It shifted it. All right, so let's talk about these. So on your graph paper, make sure you draw yourself an X and Y axis here and write down number 1. We're going to do 2 examples. So you only need 2 graphs on that front side, or 1 on each side. Okay, so tell me, yesterday we drew, I said it took about how many graphs to graph something? Or I'm sorry, how many equations? 4, correct. So I'm going to write out 4, I guess we call them what? Shells is what we've been doing. So I have y equals negative x squared plus 4 times x plus 5. I want 4 of these. I'm going to leave 2 lines to be able to do some work. Usually, it's my experience that if you know the behavior of graphs, you should be able to do it in 4 trials. If you're paying attention to the behavior of it. Give you a second to write those down. Okay, so before we start this, there's one more thing I want to do. Okay. Let's talk about the behavior of this graph. So when it was y equals ax squared plus c, what did a do? It made it narrow or wide, right? What would the negative in front of this do? Make it smile or frown, right? So this is going to be a graph that's frowning, right? Okay, so with this being said, it should be frowning. Let's start graphing this. All right, so what's the easiest number to start with? 0. I'm going to change my pen. Let's start with 0 right in the middle. If I put 0 in here, what will y equal?
5.
0 plus, no, you're right, plus 0 plus 5. So y would equal 5. So let's graph that. 0, 1, 2, 3, 4, 5. Okay, that doesn't tell me much. Which way do you want to go on the x-axis? In the positive direction or in the negative direction? Doesn't matter which one. Positive? Okay, how much do you want to go over?
2.
You want to go over 2?
No, this one. This one.
Let's go over 1. See what happens. So if I plug in 1, I would get 1 times 1 is 1, correct? With the negative in front of it, so that's negative 1 plus 4 plus 5. Good. So what do I get? 8. So if I plug in 1, I get 8. So how do I graph that? Michael, tell me where to go. Tell me where to go. The one we just did, 1, 8. Over 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's stop for a second. I'm seeing some confused looks. This is a negative 1. This is a 4. This is a 5, so 8. I plotted that first easy point, then I plotted a point to the right, and I'm seeing where it's going. Isn't this going up? But didn't we say that this graph is supposed to go down?
Yes, it would.
Good, Patrick. So you're saying it's going to eventually come down?
Yeah.
So what number, Connor, what? No, tell me. What's your question? We could. Okay, if I used a negative number for the x-axis, what do you predict, Connor? What would happen? It would be, yeah, probably. You guys want to test it out? Which one do you want to do? You want to do negative 1? Let's see what negative 1 does. If I put in negative 1, I get negative 1 times negative 1 is positive 1, but I've got a negative out here. So it becomes negative 1. 4 times negative 1 is negative 4 plus 5. Oh, I got 0. So if we plug in negative 1, we get 0. Negative 1, 0. That tells me something right there. So it's going up like this. Well, it's eventually got to come down. So
Try 2.
Try 2. If I go over 2, I think we need to go more than 2. So like 6. Connor's feeling 6. I think 6 is a smart choice. 1, 2, 3, 4, 5, 6. If I went over 6, let's predict where it's going to be. Connor, it was your pick, so where do you think it's going to be? Come on, 6 something. 6 what? If x was 6, what's y going to end up being? 5. So it'll be up here? 4? Nothing says 4 or 5. You think it's going to be negative 2? Okay, so Connor thinks it's going to go down over here. Let's see. Let's put in 5 and see what happens. 5 or 6? 6. We said 6. So if I put in 6, I get negative 36 plus 24 plus 5. What's that?
-7.
24 plus 5 is 29. Negative 7. So if you went over 1, 2, 3, 4, 5, 6, you'd have to go 1, 2, 3, 4, 5, 6, 7. You'd be down here. Let's pick something that's a little bit more realistic. So obviously this graph is going like this. Right? You don't have to do it anymore. That's enough to graph this, right?
So you just have to get it to make a U?
Exactly. You've got to get it to where you know kind of the behavior of the graph. So let's try another one. Write this one down. Okay, so before we start, let's look at the behavior. What's this graph going to look like? It's going to be going up, and there's nothing in front of the x, so it's going to be a normal looking. It wouldn't be like wide like this, or really, really skinny like this. It's going to be normal, right? Okay, so we got to draw our shells. Y equals I need approximately 4 of them, right? If I need more, I can add more, but it usually takes about 4 in my mind. What's the easiest thing to put in first? 0. I'm going to put it right in the middle because all of these graphs are symmetrical, right? So if I put in 0, what do I get?
1.
I get negative 1. Whenever something's 0 here and something's 0 here, it's got to be negative 1. So 0, negative 1. There's my first plot. Where do you want to go from here? 1? Let's put in 1. If I put in 1, what do I get? 1 squared plus 1 minus 1. 1. 1 squared is 1. Plus 1 is 2. 2 minus 1 is 1. So here's over 1, up 1. Okay, so it's supposed to be smiling. So where do you think this is going? You think we should go to the left one? Negative 1? Negative 1? If I put in negative 1, what do I get? I get 1 minus 2, which is negative 1? No, because negative 1 times negative 1 is positive 1. It would be negative 1. So if we put in negative 1, we get negative 1. Huh? Does that make sense?
Yeah.
It could. Couldn't it be? I think I just found the symmetry of it. Doesn't that mean that there must be a line kind of invisibly about right there?
Ooh, yes.
There could be. No? Let's test it out. This is my favorite when I can discover it before I have 4 points. What do you think this is going to be over here? Wouldn't it be this?
Yeah.
So if I plug in negative 2, I should get positive 1? Let's try it. Plug in negative 2. What happens? If I plug in negative 2 times negative 2 is 4. Minus 2 minus 1. Do I get 1?
Yeah.
I do. So that's it right there. Goes like this. See that? Okay, so I'd like for you guys to have some time to do this for your homework, but I'd like to talk about some vocabulary. So put your pencils down and let's just talk vocabulary. So what is the maximum height of Mario's jump if he were to collect all 4 coins? Think about it for a second. 16? Some of you are saying 0.3, some of you are saying 0.4. I want to know why. Unless it gets the twirly thing. Okay. Or it grows big, right? Some Super Mario? Is that what they call it? So, if he was at 3, listen up guys, if he were to jump at a height of 3, he would get the coins, correct?
Yes.
But the number, I mean the word maximum means how high could he get and still get the coins? 4 is right. If he went any higher than 4, I would say that he would be risking not getting those points. Can't go any higher. That's what maximum means. All right, let's talk about all this vocabulary here. Where would the vertex be? Okay, where this dot is. But what would we call that? Where's the point of the vertex on this? 0, 4, right? You go 0 on the x-axis and you go up 4. What about the axis of symmetry? The line that's going through it. So I guess if I were to draw a line, it would look like that. Let's try that one again. I want this to be nice and straight, because I'm going to move it. We call this line x equals 0. But why do I call it x when it's a line that looks like y? Because it's being moved along the x-axis. If this was the axis of symmetry, it would be x equals 1, x equals 2. Whoa. Oh, look it, I messed up my pretty theme. No, I don't. Okay, so hold on. Let me move this back. So this line moving across the x-axis means x equals something. So in this case, it's x equals 0. What about the maximum? What would we call the maximum? When it's as high as it can go, correct? So the maximum would be, he can't go, thank you, he can't go any higher than 4. Do I have a minimum on this graph? 0? This is minimum?
No, -3.
Well, I guess since there's nothing there, right? But in reality, there is no minimum. You can't be maximum and minimum, right? You can't be maximum and minimum. But that's not, oh, but truly, you can't be both. A graph can't be both. It's either or. Just like if I have a sister, I'm either the older sister or the younger sister. I can't be both. Because lines are never ending. So if I'm going in the negative direction, it could go for infinite amount of time, right? You could keep digging and digging and digging and digging and digging. So there is no minimum. There is, however, a maximum. So let's talk about with these. Thank you. All right, guys. So raise your hand. Who can tell me what the vertex is of this graph? Anthony? 0, -4. And this graph? Yes. 0, 3. Somebody different. This one, number 4. -8. 7, I think it's 7. 1, 2, 3, 4, 5, 6, 7. 7, close though. And number 6? -2, 5. Axis of symmetry. So this one would be, let's just draw them in first. Oops, wrong color. There's that one. There's that one. Here's this one. And this one. And you can't see the yellow very well, so I'm going to write it anyways. And I would call that x equals what on this one? 0. And on this one? And on this one? -2. And on this one? 0. Is this graph, this is the hardest one, is this graph have a maximum or a minimum? It has a minimum. Correct? The minimum point. Can't go any lower. Can't dig any further. Would be y equals -4. What about this one? That would be a maximum. You can't jump any higher than what? Than 3. That's the max. It's kind of confusing because it's going in the negative direction, but it has a maximum. So some students get tripped up on this. But just think about it can't go any higher. If it's going in the negative direction, it can't go any higher. What about this one? Can't go any lower. And this one? Can't go any higher. Maximum. Oops, wrong color. All right. Good job, guys. I've got one little video for you, and then we're done.